Alright, friends and neighbors, welcome back to another networking video. This time we're going to do a build, and we're going to do VLANs, trunks, and routing, and we're going to do it on Packet Tracer. And I think we'll just build until we get a little tired of building. But this is mostly what we're after. We're going to do a basic VLAN build, and we'll start there. And I'm going to talk over things as I explain them, but there's not going to be any real slides associated with this video. So we're just going to start off with a standard topology, and then we're going to build as we go. And along the way, we're going to talk about VLANs and trunks, and then routing between all of those VLANs. And of course, the encapsulation that happens when we do trunking. And so that's really, really important. And then we'll see some table updates. And I'll just talk my way through that, and then we'll finish the whole thing off with a nice trace of the packets as they flow across trunks. And if we're not too tired by then, we'll do some pruning. So here we are in Packet Tracer, and I guess I'll talk over things here too. So if you're new to Packet Tracer or trying to get your feet wet a little bit, I suppose this will help too. All right, so first of all, we'll take a couple of switches, and to remind myself to do this later on, I'm going to grab a multi-layer switch. We'll put that one over there for a sec. Now, the first thing to remember is that VLANs are logical groupings of ports. So if we pretended that this was a large switch, when we create VLANs, we're just sort of breaking the switch up into smaller switches. So that's one way to think about it. And I think I'll grab a router, do our friend the 2811 there. Alright, I'm trying to get myself used to using the gig ports that are available in Packet Tracer, because when we're going toward the center of the network, it's a lot of traffic there, and we want to use our faster links there. If you can, of course, you use gig ports everywhere, but in Packet Tracer we're sort of scaled back one generation in a lot of cases. And let's start populating our topology with PCs. Now I am going to delete PC 0 just because the numbers help me, remember which ports I'm connected to. So we'll do it that way. So I'm going to connect PC 1 to port 1 and PC 2 to port 2. So this just makes my life a little easier in trying to remember. And I'm going to go PC 3 to port 3 and PC 4 to port 4. Now, not that it makes much difference here, because we're just setting up a normal routed topology. Now, I suppose one thing that I'll remind us about is that when I have a couple of switches connected together, right, and maybe we'll use we'll pretend that the switches are not very smart, and we'll use a crossover cable here. And I have a couple of PCs that I have connected to my switches. Alright, there's a very particular reason, there's a very particular reason why, we'll stick with my convention here. There's a very particular reason why this works. And that is when we look at a switch source address table, we're used to seeing that source address tables are all about this mapping between MAC addresses and the port to which that MAC address is connected, and that's absolutely true. But of course, when we start learning about VLANs, we have to remember that in the switch source address table there's this thing called a VLAN, and that fundamentally changes the forwarding behavior of the switch. And so when we have a VLAN, it means that the switch has another decision to make. It's not just about where is that MAC address located so I can send it to the right port. It is also about which VLAN did the traffic originate on, or on which VLAN did the traffic originate. And then the rule for the switch is that you're only allowed to forward layer 2 traffic to the correct VLAN. So one way to think about topologies like this is that routers control layer 3 traffic and switches control layer 2 traffic, but VLANs are that next level up in controlling layer 2 traffic. Okay, so we have to remember that. So the reason that even if I give these two the same, a little slow here, even if I put them on the same network, what we have to remember is that there's another reason why this works. And like that. So, and the reason that I can ping between these nodes, of course, is not just that they're on the same network, right? But it's also because this PC is connected to VLAN 1 here, and this PC is connected to VLAN 1, and maybe more importantly, or at least as important, that the two switches are connected to each other via VLAN 1. So the switch says, oh, the traffic came in on VLAN 1, I'm allowed to send it out on VLAN 1 as well. All right, so we have to remember that about VLANs. All right, so let's we'll pick a network here. I don't know. Maybe we'll do 172 address space now. I've been using the 172.16 net in a lot of the demos that I've been doing, so we'll go ahead and do that. And just for fun, we'll do a little bit of subnetting here. So this is a Class B network, but we're going to use Class C default mask. Now this isn't really Class C mask, of course. When we start doing this, that means that we're actually subnetting the space. And so the network to which this node is connected is actually, well, let's make it really clear. We'll make it the 11 network, okay? And so the network, the class full network is 172.16, but of course the subnet is 172.16.11.0. And while I'm here, I might as well do the default gateway, which in this case, I like high in the range, so we're going to do that. And we'll just do a reminder here. 11.1. And so that means that up here on int f0/0, we're going to have 16.11.254. So that's what we're going to want. And 172.16.11.2. And over here, we'll do 172.16.12.3 and 172.16.12.4. Now, what I'm going to hint at right now is that your addressing and VLAN naming or numbering convention makes a difference. So good engineering practice says that when we build VLANs, eventually what we're going to want to do is have some tie back to where the nodes are, their group commonality, or the network that they're on. Okay, so let's finish up our configuration of the hosts. And I'm not going to go super fast here because, you know, if you're following along in the home game, we want to keep up, right? We want to make sure that nobody gets lost. All right, so that's those two sorted, and let's do our other side, and then we'll work on the router. So on this side, the default gateway will be 16.12.254, and let's go to our interface. Oops, 12.3, I think I said I wanted to do. Now I guess by subnetting it keeps wanting to fill in the class full mask, but I'll have to keep editing that. Hopefully I'll remember and won't miss anything. Okay, 12.4 255. Remember that for the hosts, the mask makes a difference because they believe they're on a different network. So the processing on the host routing table makes a difference here. All right, so that's all of these nodes, and remember that by default everybody is in VLAN 1 here and everybody is in VLAN 1 here. Now you don't even need to believe me, I will prove it to you. Right, so as an example on switch 1, and actually let's do this while we're here. so that I know who I'm talking to. So we're going to do a host name command, and I'm going to say, well, you are switch 1. Oops, let's not get too crazy with our, there we go. And we can see that my interface changed. Okay. So we'll do a show VLAN here, and we can see by default I have everybody, including my uplinks, in VLAN 1. And that's important because that means that anybody connected to this switch here can see the broadcast and multicast traffic of everybody else. No to the initial configuration dialog. And so let's, oh, it's just one router, right? 2 interfaces. So to get that, to get the routing table, all we need really to do is give it its IP addresses. So first, let's do our host name here. Oops. And we will call you, of course, router 0. All right. We're going to go to intf0/0, give it an IP address. And the gateway that I was using down below is the one that I want to use here. And the same mask. There we are. And we'll no shut the interfaces, and we'll see it go from red to green and amber. There we go. Now we'll go over to intf0/1. You don't have to navigate up to get that. This is 12. And of course we'll do the no shuts here too. Now the minute I do that, as you can see, the interfaces are trying to come up. And I'll do a show IP route. And we can see a couple of entries here. So this entry means that the 11 and then the 12 net are directly connected to these interfaces, F0/0 and F0/1. And then this entry here is the IP address that's specific to that interface, and that's why it has a /32 associated with it. So the /32 just simply means 255, 255, 255, 255, and so if you AND those two together, you get the IP address. So that's how the router knows who it is, and that's it. So let's see if we can ping between our nodes on different networks. 172.16.12.3, that's where we want to go. Now, the first one is going to delay because, well, we might as well do that. We'll do the simulation. And we will filter out a couple of things. We're not worried about these in this video. There we go. Whoops. Okay, so now we're going to ping between them. There we go. And so now the ping is away, and we've got queued up an ARP and an ICMP. And we will send this up, and it gets to the switch. So first of all, the host processed its host routing table, right? Found out that the destination was on its network, or I'm sorry, the destination is not on its network. And so who does it need to talk to? Well, it should say I need to talk to my default gateway. And if we look at this ARP message, right, we see that it is ARPing for the MAC address of its default gateway. All right, so that's just simple processing of the host routing table, and then it looks in its ARP table to try to find the entry, and it's not there. So it goes up to the switch, but take a look here. Notice that it went down to PC2 and then up to the router as well. Why? Well, a couple of reasons. One is the default behavior for a switch on broadcast traffic, broadcast layer 2 traffic, is that it's got to forward it out all ports. I'm going to add something to that rule. So it's all ports except the one that it came in on, and trunks, which we'll see later on. So it went down to PC2. Well, because PC2 was not only on the switch, but also in the same VLAN. That's really, really important. Okay, so same thing over here. Now we got the router ARPing for this MAC address, right? So that's what happens over here because we have to build a new frame. So the router is looking for the MAC address that goes along with 12.3, and we can see here, I'll remind us about a couple of other things, right? This is broadcast layer 2. There is no IP header, and the ARP type is 0806 in hexadecimal. And so this looks like it works pretty well, going all the way across. Now, because of all this ARP stuff, a lot of times the first message times out, and I'll show you what I mean by that. If you've never seen it before, There it is right there. So this timed out because, we had to handle the ARP traffic first. Now the next time we do it, it won't time out because we've already done the ARP exchange. Okay, so that's pretty straightforward. But when we look at this, I say, oh my goodness, this is very, very wasteful. So what I think we can do is we can get rid of one of these switches, right? I'm gonna dump, and maybe we'll just disconnect it. So we will we'll disconnect the switches here, and I'm gonna reconnect to switch 0. And I'm just gonna pop it over here, and I'm gonna go high in the range 2. Let me see. We'll use gig. Oh, that'll work. We'll use gig 2. And then maybe PC3. We'll go over here to port 3 again. And PC4 will go to port 4. And we'll just put this up here for right now. Everybody was in VLAN 1. Alright, so now, what's our status? Well, everybody's still in VLAN 1. So, one question would be, what's the difference in behavior? Well, by getting rid of this switch, we didn't actually at this point change the behavior at all because everybody's still in VLAN 1. What we did do is we made our boss happy because we just saved on heating and cooling. So we don't have this extra device. And so now we can be more efficient with the ports on this particular device. And so here's a question. How does this thing operate? I mean, why can't we just do this? Why are we talking about VLANs at all? And that's a good question, but what I'm going to do now is I'm going to ping between a couple of devices that are on the same network. And be mindful that these two are on a different network entirely. So we'll do our simulation again, and I'm just going to ping 11.2, which again is on the same network. So what do we think is going to happen? Well, same thing as before, right? We queue up the ICMP and ARP because now we're talking to this node here, but we've never talked to that node before. And so it goes up to the switch, and it's an ARP request. It's a broadcast message. And so we got the broadcast frame, and we've got the type 0806. We're looking for the MAC address that goes along with that IP address. Well, it gets to the switch. Oh my goodness, the switch sent it everywhere. Which means that two nodes that are not even on the same network heard this broadcast traffic. Now, if you're a bad guy, you would hear the traffic too. And so we don't want to have all of this traffic that's broadcast and multicast go everywhere. So that is a fundamental problem with just using layer 2 devices and not doing any VLANs. Okay, so we'll go back to real time here, get rid of all this stuff. Now another issue, of course, is if there's a problem with one set of nodes, then we have limited ability to contain the problem. So that's another reason why we want to use VLANs. Okay, so what we're going to do is we're going to go into the switch and create some VLANs. And I'll add ports 2 ways. Oh, I never did the host name here, so let's do this. Hostname switch 0. There we go. And I'll show you the standard way to add a port to a VLAN. So that's just interface F0/1, and we want to do switch port access VLAN 11. Okay, and then we'll do the same thing with port 2. Now, if you had a lot of ports, you wouldn't want to do it this way. So you would instead do interface range. And then we'll do F0/3 to 4. And then we will do 22. I'm sorry, 12. Okay. Well, what did I just do? Well, just put everybody in their own VLANs. Okay? So before, without VLANs, it still worked, but we had all that traffic being sent everywhere. Okay. By the way, it would have worked also pinging across to nodes on different networks. Just because you're connected to, you're on different networks, doesn't mean that when you connect to one switch, it doesn't work, right? It sort of stands to reason. All right, so let's see if we go across. Does it work now? We'll go 12.3. Now we just killed off the interfaces, so the ARP tables are empty, so we got to refresh the ARP tables here. And so remember that the ARP goes, we got up and down here, and then we've got on this side. And unless I forgot something, which I may have done. Oh, I know what I forgot. Okay, so I created VLANs and I put, so let's do this. So if we pretend that a VLAN is sort of a box, right? What I did was, and actually I got two boxes. And so maybe this box over here, this is the VLAN, oops, VLAN 11 box, and over here is the VLAN 12 box. And so what I did was I put the PCs in these boxes, or these logical groups like this. But I forgot to put my router in there. So I've got to put, whoops, I've got to put this router interface in this box, and I got to put this router interface in this box here. Alright, it'll be, can't really split my router in half, but let's fix that. Okay, so those were attached to these gig interfaces. You can see that the gig interfaces here are still in VLAN 1, and so that's a problem. So G0/1, we want you in VLAN 11, and 2, we want you in VLAN 12. Alright, so now if we go back to our PC, I guess we'll wait for this. Well, I'll show you one little tip or trick while we're waiting. If this annoys me, what I can do is the reason that this delay is there is because of spanning tree. So I can do something called spanning tree port fast, and that'll bring the interfaces up much more quickly. So that is something that you could do. In fact, you can do it with an interface range command. Let's see here. Oh, for heaven's sakes. Range. So if I wanted to do everybody, I would do something like this. And then just say spanning tree port fast. So that command again was this here. And what that does, it tells the port to not do spanning tree discovery. Now, spanning tree is a different thing that we're not going to worry about right now, but there we have it. Okay. Well, I'm going to, well, maybe, well, I guess we'll go back this way. Okay. Well, so now this group of nodes is in VLAN 11, and that group of nodes is in VLAN 12. Maybe I'll get rid of these boxes now. Yes, I do. Yes, I do. All right. Well, now let's say that we want to add our switches over here to the party, and maybe we'll put, this PC on the same network as the, one of these networks over here. So selecting at random, maybe we'll just do the one on the far side, 11.5. Well, there's a couple of steps that we got to do, and a couple of ways that we might approach this. I might say when I connect to, I could just say, well, I'm going to connect these two switches together, like so. Right? I don't even know what port that was, but so I connect these two together, and I say, all right, let's properly configure my host here. The default gateway for this one would be 172.16.11.254, and the IP address is going to be changed, of course, 11.5. Whoops. You can see by the number of times I say whoops that I make a lot of mistakes, but that's okay. And so now the question is, all right, can I ping? Let's try something easy. Let's try my default gateway. So can I ping 172.16.11.254? I put it on the same network. I connected the switches together. I don't think it's going to work. So that's a problem. Well, how could we fix it? Well, what I could do is I could say, well, I'm going to connect this switch. Whoops. See, it's not working here. I could say, well, let's get rid of this connection. No, I don't want to do that. Let's actually take this connection, and I'm going to put it in, since it's PC5, we'll stick with our convention, PC5, right? We'll do that. And what I need to do is say, well, this PC5 is in on a different network, and we already know that we put these guys in a network or in a different VLAN. So what I want to do is put this PC in the same VLAN, in the same box. So we need to do a couple things if we're going to do that. So on switch 2, we will say that port will belong to VLAN 2, or VLAN 11. So let's try that here. We'll see. We'll troubleshoot along the way, see what works, see what doesn't work. So first of all, we'll do our host name, and this will be switch 2. And let's go to int of 0/5, and we'll say switch port access VLAN 11. Okay, so we do a show VLAN, and I created the VLAN, so that's good. And well, how about this port over here? We probably ought to do the same thing with this port over here, right? So we're going to do int of 0/5, and we'll say switch port access VLAN 11 again over here. All right, cool. So this port is now in VLAN 11. So we did this, right? VLAN 11. We've got VLAN 11 over here. So that seems pretty good. Now before we go anywhere, let's see what's happening on switch 2. All right, as the ports are going to come up. Whoops. There we go. So we're doing more spanning tree discovery here as we see. And is there anything going on over here? Well, oh no! What's happening right here? We have a native VLAN mismatch. So this is a very common problem when you're setting up your switches, but it's really handy to know why we get this. Well, first of all, we have to remember that the switches are actually communicating. They're doing Cisco Discovery Protocol at this point, they're doing spanning tree, they're doing dynamic trunking protocol, and this switch has just said, listen, we've got a native VLAN mismatch. And the reason that there's a native VLAN mismatch is because this port right here is in a different VLAN. It's in VLAN 1, right? So that was, right, port 22. Port 22 is still in VLAN 1. Okay, so we can solve that problem. So let's do that. So we will just say, okay, port 22, and then VLAN 11. Now, let's see. This is on VLAN 11. Over here is VLAN 11. This side is VLAN 11. So we can say that this whole point-to-point link here between the switches is VLAN 11. So that makes me happy. And then we will go ahead and say, well, in a second, I should be able to ping my gateway. Come on, spanning tree. I think at this point I'm going to start doing port fast everywhere. Hey, look at that, it works. Okay, I'm very happy. I'm very excited about this now. I'm very excited about this. Now, by the way, why might I take a PC like this that's on a different switch and try to put it in the same VLAN as these guys over here? Why don't I just connect this PC to this switch and put it in the same VLAN? Well, what if this switch is in a different building or, on a different floor? So there's a lot of reasons why distant PCs might need to be on the same VLAN as folks that they regularly communicate with, or with folks with which they have a similar security concern, need access to the same services, things like that. All right, so let me see if I can get all the way over. Let's see if I can get to somebody on the 12 net. 12.3 maybe. And we'll see if that works. All right, after the ARP exchange, there we go. So that works. Fabulous. I feel very good about this. So now let's expand our topology a little bit. I'm going to add somebody up here. And I want this node to be, oh, I don't know. Let's do, well, it's .7, so we'll do 172.16.12.7. All right, very good, very good. So we'll configure this node. 12.7. And change it to mask. And give it a default gateway. 12.254. Now we're learning, right? We know that when I take this PC and I connect it to the switch, I've got to go into this switch now, switch 2, and say, I'm learning, so I want you to be a part of VLAN 12. There we go. All right, terrific. This should work. I feel good about this. I feel good. So now I'm going to go to my desktop here, and all I want to do is ping my default gateway. Oops. Oh, for heaven's sakes. 16.12.254. We'll wait for that to go green. It takes 30 seconds, by the way, for those of you who didn't are not spanning tree enabled yet. There we go. We'll let fly. Oh, I don't feel good about this now. I got a queasy feeling in my stomach. I think we got a problem here. So here's our problem. All right, this is VLAN 12 here. And the issue is that suddenly I've got VLAN 12 on this switch, and I've got VLAN 11 on this switch, and I took this doggone connection and made it part of VLAN 11. So that means that while it worked for this node, it totally doesn't work for this node. And that's the issue. Okay, so what we've got to do now is we've got to get rid of this. We've got to say you are no longer in VLAN 11. And actually, let's do this. We're going to get rid of you. All right. So what we're going to do instead is we're going to say, I'm going to take this link and I'm going to move it to a different link. I'm going to say, let's use our gigabit links here. Oh, you know what? I think I burned my gigabit links on the other side. So let's do this instead. We'll use port 23. And what are we going to do with port 23? Well, we're going to do a couple things. First of all, we'll take a look at where it is. So port 23 is part of VLAN 1. Well, we know that's not going to work because the other side has VLANs and things like that on it, so we can't connect VLAN 1 to anybody. And we can't use VLAN 11 and 12 because that isolates other nodes. We need a trunk. Okay. So what we're going to do, I don't know why I closed that. So that was VLAN 23, or port 23. Oops. And let's go to int f0/23. And what I'm going to do is convert this to a trunk port. Now, a trunk port is not an access port. It is fundamentally different. One of the special things about VLAN 1 is that it's what we call the management VLAN. Well, why do we call it that? Well, we call it that because it's also the native VLAN. What does that mean? Well, native VLANs are untagged. So the traffic is allowed to flow everywhere, which makes it easy to manage devices. All these other VLANs are tagged VLANs, meaning that they have a trunking tag. We'll see exactly what that means here in a little bit. So what I want to do is I want to create a trunk port, and the difference between a trunk and an access port is that trunk ports do tagging. So we'll see how that works here in a sec. So I'm going to say switch port mode trunk. Okay. Now, in the real world, right, the minute you make a trunk somewhere, there's a lot of auto negotiation that goes on. But I am going to go on both sides. You see this? Inconsistent port type. So what I'm going to do is I'm going to say, all right, fine. I'm going to solve all of these mysteries, and I'm going to say both sides are going to be trunks. Okay? And while I'm here, we'll do spanning tree. Well, actually, I should not do that here. The minute you're talking about links that are interconnecting switches, you definitely don't want to do port fast. Port fast is just for ports connected to end nodes. So we'll let spanning tree do its thing here. By the way, while I'm waiting, what am I talking about with all this spanning tree? Spanning tree is what protects us from loops in Ethernet networks. So here is details about spanning tree. Okay, so there we go. It's just a little eye candy while we're waiting. All right, let's see if this still works now. So now I want to ping from my node on VLAN 11 to somebody that's on VLAN 12. All right, so that still works. Now let's go from somebody on VLAN 12, and maybe we'll trace the simulation here a little bit just to see where it goes. And we'll go to 11.2 because that one's not getting any love right now. So there we go. All right, so we're queuing up this ICMP and ARP message because we got ARP for our default gateway, right? Host routing table goes up to the router. Oh my goodness, it went to everywhere on VLAN 12 because that's where I started. And then down, back across, here's my MAC address. Here goes the ICMP. There we go. Up to the router, back down. And the router is now ARPing for 11.2. 11.2 answers. Here's my MAC address. And then we try it again because that one timed out. All right, up to the router, down from the router, and then down to the host. And we see that it works. Huzzah! Okay, so our trunk line actually worked. Now I see that we're getting a little long on time here. So I'm going to pause the video, and we are going to do this in a part 1 and a part 2 thing. So I will see you in part 2. We'll trace this through and then extend our network even farther.